Welcome. In this video, we are going to review a machine learning interview question. We are going to look at that's a question from my ebook. In my ebook, there are three sections: one about easy questions, medium questions, and advanced questions. This one is an easy question. Basically, it asks the candidate to compare hyperparameter tuning methods on especially grid search, random search, and Bayesian optimization. So let's start with grid search. If likely you've already used it. For example, let's say you start using machine learning. You do machine learning with skitlearn, for example. You try a few hyperparameters for your algorithm. So usually what you do, you just do a for loop. Let's say you have three hyperparameters. Then you create a few nested for loops. And for each hyperparameter, you try different values. And then you can you do cross validation, for example, on you select the best hyperparameter. So basically the idea is really, as the name suggests, you create a grid. You create grid. You really create the product of all possible combination of parameters. So you, for each hyperparameter, you choose discrete values. You choose a finite set of values. And then you compute the product of all possible solutions and you try them. As here is explained in this answer, the issue is that the number of possible combination grows exponentially. For example, let's say you have only 5 hyperparameter that you want to tune, and that's really few. And that's for all of those 5 hyperparameters, you want to try only 5 values. Then you already have 3,000 distinct configurations to try. If you have a simple algorithm with skitlearn, maybe it will work, it will be okay. You can run that with a finite compute budget, but with a current state-of-the-art machine learning algorithm, it's not feasible. Let's say, for example, you train a diffusion model, it might each training might cost between 10K and 500K. You cannot run so many. You cannot do so many trainings. But okay, so that's the grid search. Another approach in the same idea, but a bit better. Each answer is always supported by references. So you might have a look at in the reference there are papers that are cited on that show that random search will give usually better if you are given a given training budget or compute budget. Usually random search will give better hyperparameters than grid search given a compute budget. But random search, what it does, you just, for example, select bounds for your hyperparameters. For example, you say, okay, my learning rate should be between 1e minus 2 to, from 1e minus 8 to 1e minus 2. And then random search will randomly select hyperparameters between those bounds. It will do the same for all hyperparameters. And by sampling randomly, rather than having predefined values, random search will give better answers by evaluating the high dimensional space more quickly. Okay, so that's random search, but there is an even better way to do the tuning, and that's Bayesian optimization. I will put the link of the ebook in the description if you want to read that in detail. But here really the idea is a bit like when we do machine learning, we evaluate a function with some input and output. We assume that there is a function that maps the input to the output, and we try to fit this function. Here the idea is exactly the same. So we assume that there is a function f of h. So h is our vector of hyperparameters. And this function f of h will give you the validation score, for example, or give you the test error, for example. So basically you map, okay, if I have this set of hyperparameters, and if I am able to find this function f, then I will know for each hyperparameter what will be the validation score, for example. So let's assume that we have this function f that's really powerful, right? You can, For any given set of hyperparameters, you will know how well the algorithm will perform for those hyperparameters. And therefore, you can very easily select the hyperparameters H. So now the question is, how do we get this function f? Well, in the same way that than when we do supervised learning. So, but the issue here is that we don't have huge data sets. So what we are going to do, usually to fit this function s, we are using Gaussian process. If you're not familiar with that, I will invite you to have a look at Gaussian process. I have upcoming videos about it. But okay, so basically you use a Gaussian process to fit your function. That's often the case, but not always. So for example, you could use just a neural network to approximate f. But basically, what you will combine some kind of active learning. So first, you will gather data points over time. So first, you do one training. So you randomly assign some hyperparameters h. You do one training, you get the validation score. Okay, and then you have one data point. And then, for example, you can do that 10 times. So now you have 10 data points, and now you start with enough data points to fit your function. So basically, with those 10 data points, with those 10 pairs of hyperparameters on validation score, you can fit your function. And then you will try new hyperparameters to get new validation score, but you will not do that randomly. You will use your function f to choose which are the best hyperparameters to choose next. On here, we have this exploration trade-off, a bit like in reinforcement learning. Either you can choose hyperparameters that will give you a high validation score. So basically, you want to exploit the function. You want to go in the region where you know that the validation score is high. But you can also go in the region where you have high uncertainty. So basically, your function f, there are well-explored regions. So the function there is like great or has high confidence, but there are also regions that are unexplored where we have high uncertainty. So what we can also do, we can explore a bit more. We can, we have really this exploration trade-off, really like in reinforcement learning. And the idea is to acquire for each run, each time we do one training, to maximize what we get out of it. And basically, by doing it that way, rather than just doing a grid search or by doing randomly, if we're not doing fully randomly, we're reusing the information we've learned from previous run, and we're using that in an appropriate way, so that we know which are the next hyperparameters I should use to get the most information out of it. Okay. So this was a very quick explanation about those three methods, but I would invite you to have a look at papers about them to understand that a bit better. And I would advise you to play with Bayesian optimization. There are a lot of great frameworks to do it. For example, Optuna. Maybe I will make a tutorial about it at some point. You can also do it with weight and bias. So I really hope you like this video. We are going to treat more advanced questions in my next video. So please subscribe, like this video, comment it to give it some reach. Thank you very much.